So if we have a look at an example of case 1, we've got a table here that gives the rank and population of the UK's largest cities and districts. And we've got rank as a variable R and population as a variable P. And this relationship between the rank R and the population P is being modelled by the formula P equals A, which is just a constant, times R to the N, which is just a constant. So immediately you should be able to see that that is very similar to our Y equals AX to the N. P equals AR to the N, so P is the same as Y and R is the same as X. The first thing that they want us to do is draw a table giving values of log R and log P. So we just take the values of R and we take the log of them, values of P and we take the log of them. And these two corresponding values, this is a coordinate at the moment, 2, a million. We will do log 2, log a million, and that will give us this. Log 2 will give us 0.3, log a million should give us 6. So these two values here, correspond to these two values here. Same with these two. If we take log of both of them, we'll end up with these two. These two, take log of both of them, we'll end up with these two. My camera work is shocking, I'm aware. Apologies. So once we've got this table, that's answering part A of the question, we're going to plot a graph of log R against log P and draw a line of best fit. Now, if we look in the original equation, R is the same as X. So log R is going to be our X-axis, log R. And P is the same as Y. So log P is going to be our Y-axis. So we've got log P against log R, and we're just going to plot each of these coordinates. So we've got 0.3 against 6. I've got 0.48 against 5.86, and so on and so on, and then a line of best fit has been drawn. The trickiest bit is this part C. Use your graph to estimate the values of A and N. So there from our original equation, P equals A times R to the N. And we're going to do the same as we did in case 1, the general edition, which was here. We had Y equals AX to the N, and we turned it into Y equals MX plus C. So we've got P equals AR to the N, and we take logs of both sides. Using the log laws, this log of A times R to the N can become log A plus log R to the N. Then using power laws, we can bring that power down. So we've got log P equals log A plus N log R. Now this graph is log R against log P. So N is the gradient. And now in the question, they've said they've read the gradient from the graph. So they've done exactly what you would do in the normal GCSE. They've created a right angle triangle. They've done difference in Y over difference in X. So that gives us N, which is the gradient. Based on this equation, log A is going to be the y-intercept, which again you can see here. Log A is equivalent to C, the constant. So log A is going to be the y-intercept, and we just read that off the graph, and it looks from the graph that it would be 6.2. So log A is going to be equal to 6.2. But the question hasn't asked us for the value of log A, it's asked us for the value of A. So if log A is 6.2, remember that when log has no base written down, it's log 10. So we use logarithms. If log A is 6.2, then 10 to the 6.2 equals A. So A equals 10 to the 6.2, which you can just work out to two significant figures to be 1.6 million.